Hey everyone, so I had a comment come through in one of my other videos saying, hey, could you do a walkthrough on what you're doing with the Holley EFI? So here it is. Here's my personal tune-up. I will kind of walk through everything that I'm doing with it. And I hope this helps you guys understand a little bit more about the Holley. If you would, please hit the subscribe button below. Open global folder or file, open data log if you want to look at the old data logs, download from ECU. So key on, download from ECU, and then it will load the tune-up that's in the car currently. Create a new global folder. And then this is where you can open up previous stuff. And here's my tune that I have in it. It's the hard tire pass from the last pass in the video that I made. That's the last pass I made in the car. So you can either pull open files from here, or you could just open up and go to File, Open, and get to your files there. So I'm going to go ahead and open up my file that I've had. And so here you have your fuel graph. As you can see, fuel graph, learn table, target air fuel. So we can go through that whole thing. So here's the table, and then the fuel graph that matches the table, the learn table, and this is when the car was running, where it was changing. So you can see, like right here, it had 28% change. But what I learned is, after looking at a lot of data, the shutoff switch got pushed. So it was a little loose, so it actually got shut off. The shutoff switch got shut off. So as the run was going on, the car was losing battery power, which was causing voltage to drop, which was causing the fuel pumps to be less efficient, and therefore causing a leaner condition. So the Holley went ahead and added fuel to make up for the difference. The car ended up kind of popping and shutting off, went ahead and figured out that it was the switch. So something to figure out there. So I'm not going to save these. I could either transfer learn to base or clear the table. I want to clear the table because I don't want that getting transferred to the main fuel graph. So I went ahead and cleared that. It sets it all back to regular. Target air fuel ratios that I have set up through here. And then this is kind of where you would start at idle. I have the car idle and rich. I'm using air fuel on this for gasoline. The car's on E98, but just from me, from the very first time of using it, I've kind of trained myself and learned to figure out kind of where I'm at lambda-wise based on air fuel of 14.7. The Holley will let you select methanol or ethanol, race gas, and a few other options for what scale it's going to use. So acceleration enrichment, you have all these in here. Fuel modifiers. So as you can see, something that a lot of people don't know is that to get the Holley to use the learn function, you have to zero out all of your fuel modifiers. The fuel modifiers in here is coolant temp enrichment, air temp enrichment, and fuel control. So on these, 100 is 0. Above 100 is positive, and below 100 is subtracting. Air temp at 100. I'm not gaining, I'm not losing. I just want it to stay there. I don't want it to modify the fuel at all. So if you start adjusting these, it will not use the learn functions. Startup enrichment, cold starts, all of that type of stuff. And then you have your sensors. So when you first set up a car, you want to go through and set all your sensors. I use a GM 3-bar map sensor, as you can see here. Coolant temp sensors, a GM LS coolant temp sensor. Manifold air temp, I used a GM manifold air temp sensor. And Holley sets some in here, or you can always set up a custom. Oil pressure, I used a custom oil pressure sensor. It's actually a GM oil pressure sensor for a Corvette. I just took the numbers from it and built this graph right here. So it's all based on voltage of the sensor and the reading you want it to give. So you can kind of build your own sensors based on what you're using. Fuel pressure, I'm using the Holley 100 PSI fuel pressure sensor. And you can, if you know that it's reading wrong, you've double checked it, you've calibrated it or whatever, you can offset it. And you can do that with a lot of the sensors. You offset it a little bit in case the sensor's a little off. So as you can see here on my coolant temp sensor, GM, and I used ambient air temp, and then it was 15 degrees off. So I checked it, and then I went ahead and offset it. So that sensor was a little off, went ahead and offset it, and now it reads correct. here's kind of your main setup when you're first going into setting up a Holley. So on my car, it's 8 cylinders. It's a speed density tune. I'm using one NTK O2 sensor. That's another thing with the Dominator is you can run 2 O2 sensors. With the HP, you can only run a single O2 sensor. So startup settings for clear flood TPS. Some of this stuff was already set from the GM base tune that comes with the Holley. Some of it I didn't even mess with. Fuel system makes it real easy. Multi-port. Fuel pump primes 5 seconds. You can adjust all that. Minimum injector time. Because I'm running the Bosch injectors to get it to idle correct, it idles a little rich. But I had to set the minimum injector time on the injector. Otherwise, it would get into an unstable state down low. So that's what I've done there. So it's a little bit more than what most injectors would be. System type. So Bosch 160s. Actual fuel pressure. I was telling this that I'm setting at 43, and then on the car with the regulator I set it at 43. So then it can calculate all your fuel flow, pounds per hour, and everything within the tune-up. Injector sets 1. If you had multiple sets, you could put this in there. Sequential and injector end angle 0. So I'm just, a lot of the stuff I've left from the Holley and what it gave me. If I didn't know or I didn't know any better of what I needed to adjust, I've just left it. So they're low impedance injectors, 160 pound, and then it goes through here and it gives you your voltages. So if you're adding sets or you had a custom set of injectors, that's why it's always important to order a set of injectors that is well known, that comes with a sheet that can give you actual voltages. So you can give the computer system, no matter what system you're on, you can input in the correct injectors for what you're using so the computer can calculate. So then I can go into, so here's where you can go HP to Dominator, real simple. It's only 2 options you get. Ignition parameters. So here is, being a turbo car, I have my rev limit, my main rev limit here, and then it is a 24 tooth Gen 3, and you can change that depending on what you're doing. As you can see, Hemi, Modular, Coyote, so all the different ones. So rev limiter number 1 is my 2-step. So before I've had it at like 4,000s where I would usually leave on the 2-step, doing hard tire testing and everything else. I'm cleared down to like 3,250, 3,200, and I'll probably adjust that some more for the next time out. Firing order, knock sensors. I'm not using the knock sensors. I had some false knock. I tried to use them and it would jerk timing out of it right away. And whenever you start going solid motor mounts and things like that, sometimes you start getting false knock and it picks it up. And it's a really weird feeling when you launch the car, it starts making power and then just falls on its face and you look back and it's the knock sensors pulling knock. So I've just done away with those. I've reverted to making sure I watch plugs and that I'm not giving it too much timing to where I'm running into detonation. Rev limiter 2, I'm not using it on my setup. On Jared's setup, as you've seen me in the other videos in the Blue Nova, we've used rev limit 2 as his 3-step. So we use the 3-step, he comes up on the foot brake, it's a lower rev limit, and then when he grabs the trans brake, it moves it to the rev limit 1, which would then be the 2-step. So cranking parameters, those are already preset, real simple there. Sensor scaling, so this is where you can go in and set all your sensor scaling. I really haven't done much here. I'm using a lot of factory types sensors. Basic I/O. So I am using one of my outputs to control my electric fan. 185 degrees on, 175 degrees off. You can do that. You can control as many fans, as many things as you want with the Dominator. I'm only using one here, and then the other one I kind of just have as a manual wire up or a little coolant temp sensor that turns the fan on and off mechanically. So I'm not using up all my I/Os, but I am controlling one of the fans with an I/O. Fuel pumps, secondary. So if you're running 2 fuel pumps, you want it to come on boost reference or whatever, you could do that through the Holley using an I/O. On my car, I'm using a Hobbs switch that turns the fuel pump on at 7 psi. It's a little pressure switch that ties into my distribution block. Air conditioning, race car, no air conditioning, so I'm not using that, but you could use this to turn it on and off. So then you have some other things, timing retard, TCC, data log, CAN bus. I can get into data log a little bit more. If you come into data log and you go into setup ECU logging, As you can see here, I've set up mine to work off a trans breaker. As soon as, so actually I've done it where I've turned it on with the trans brake, but then you don't get any burnout or anything like that. So I've changed it to where it's a normal data log triggered 25 frames per second. You can set it for 60 seconds, 3 hours, 10 seconds, whatever you want. I do 60 seconds. I figure that's enough time to get through the burnout. If there's any sort of slowdown or whatever there, it'll go past that. And then my trigger input is TPS is greater than 90%. So I usually will go full throttle to get the tires to break loose in the burnout box. So as soon as I start my burnout, it will turn on the data logger. I've also set it up, like I said, off of trans brake input. I think I've done, and it's been finicky, so that's why I've moved to TPS at 90%, because the only time you should go to 90% in the car is when you start your burnout or when you're staging the car and coming up on the two-step. So then closed loop learn. As you can see here, this is where you start getting into more of your tuning things, and you guys need to be careful when you're doing this, especially if you're new. So I've dialed in my idle area, and I'm not letting the computer correct at all. Slightly outside of that, kind of in cruise, in kind of the weird areas, I have left 30%. It can adjust a little bit. It really doesn't do much anymore. And then out through here, as you can see, I was like 80-80. It's probably playing with that area, but up here, full throttle, I've set it to where it's 70-30, 70% correction. I'll let it add 70% fuel, but I will only let it take away 30% fuel. So if I have a glitch in the fuel system or whatever, it can add a bunch to it to try to save the car if something goes weird, but it can only pull 30%, which is still a lot. I've been really debating, and I'm going to here soon, is adjust anywhere that I know is tuned incorrectly to only allow like a 6% change. That's a double-edged sword, or not 6%, but like a 10 to 20% change. I've looked at a Copo Camaro before, and they allow 10% over the whole fuel map. 10 to 20 isn't bad. If it goes 20% lean, though, that could be dangerous. I have seen it where a car with a Bosch sensor ended up failing, and it tried to add a ton of fuel in a certain area because it actually read lean. So it threw a whole bunch of fuel in the map, messed the whole map up. So I went in and I had to go 10% across the whole fuel map, and the car ran super consistent. It was like a big block dragster, and it ran really good, and everything was fine. I verified that the fuel wasn't adjusting a lot, so we're good. But as you can see, like where the fuel pump was losing efficiency when I was losing the electricity, and I was losing voltage, so the pump wasn't able to produce as much for what it was trying to command. It actually tried to put a bunch more fuel into the system. So it is nice. It's a nice safety feature in the Holley. If you leave the compensation on, if it sees a real lean mixture, it will start adding fuel. But also, on the other side, if it starts seeing a super rich mixture, it will start pulling fuel. So within here, you can adjust. So that's the upper numbers, how much fuel you let it add. The lower numbers, how much fuel you'll let it take. So I don't allow it to take any here, only a little bit of cruise. Like right here, I don't know why I have 0, 0, 0, and then 30 right here. I was probably trying to tune in that one little area. So if I want to go 0, makes all those 0. So now the computer will not adjust at all in that area. Same up here. So if I want to go out through here and go 70, allow it to add up to 70% fuel, and then remove up to 30. It's still aggressive. I feel that once you have your fuel map dialed in, you should pull those numbers back in case you have a sensor failure. All the EFI cars are great. They work super, super well. But when you have a sensor failure, if it could go one way or the other, and then it tricks the system into doing something else. So when your fuel map's set, you can lock those numbers down. You can literally tell it to not adjust any. But with the way that elevation changes, density, altitude, and everything, you might as well use the EFI system for what it is and at least allow it to correct maybe 10%, maybe 20, maybe 20% rich, 10% lean. So then it can add some fuel if something happens and it needs it. So a lot of times, unless there's something weird, kind of with what happened on my last setup, is I've only see about 4 to 7% adjustment pass to pass to pass. So when you get down to those kind of numbers, you know you could put a 10 to 15% correction in it, and it really will never get past that unless there's an issue. So it's something that you as the owner, the tuner, whatever, have to decide how much you want to let the computer take the wheel and do what it does. And when it works great, but I have seen it where if the O2 sensor fails, it will mess up it will either add or take fuel more than it should. So just something to keep in mind when you're tuning with a system like this. So I'm going to go ahead and do the same here, 70, 30. When you're first angling in a car, I leave it at 100, and I keep my eye very, very closely on the air fuel. Usually the idle, big cams, a lot of things, or you're letting it idle rich because of the way that the injectors are or whatever. I try to tune that all in by hand. Maybe I let it get it close and then shut it off and then go back and adjust to get that real nice, consistent idle air fuel. But otherwise, up through the upper portion, I leave it at 100%, and then I just kind of creep into boost, and I keep a really close eye on the air fuel reading on the Holley. And if it starts going lean at all, I shut it down and work back up to it until it's nice and consistent and it's working well. So individual cylinders, you can adjust timing. So if you have a nitrous car and you know that it hates that number 6 or 7 cylinder or whatever in an LS, then you can specifically go in and pull timing out of each cylinder. So if you have that one cylinder that always seems to melt the spark plug, or you've heard it before or whatever, and you just know that that's not the cylinder that likes a lot of timing, you can pull timing. Additionally, you could add timing in certain cylinders, so you could literally take timing per cylinder and really get that tune-up very precise. So here's your inputs and outputs. The rev limiter 1, ground, the J1A3, if you print off, get from Holley the I/O harness, and you go into their little PDF, and it will tell you which one's which. And then you base it onto the ECU pin, and that's how you figure out exactly what you're doing. Electric fan 1's J1B12. So there's a little bit of things. That's a whole nother subject, is getting into wiring on the Holley. But the information's there. Take your time, read through all the information, and it's really not that bad. So we went through all the system parameters there. And then, so here's the idle parameters, idle settings. And this is where you can come in here in idle settings. A lot of the stuff I've left the same. And then, but it is a GM stepper motor. You just kind of set it, you go through the settings, and you tell it what you have. Idle speed. Here's the idle speed, kind of where I start my car, 1200 RPM, and I bring it down to right around 1000. Idle air control parked, and then when the car's on and running, it'll give you a little bubble that floats around right here. IOs, trans brake ground, J1A3, dome pressure, and then when you're doing the outputs, and then inputs, outputs, and then you can also do the pin map for that. So this is when you assign it over in that inputs outputs, it'll show up here. You can grab it, drag it down, and drop it into here. And then that's how you work it. So my rev limit 1 is tied to my trans brake launch and my trans brake input. This is dome pressure. So on the boost controller, it learns the dome pressure by a Holley 100 PSI switch. So I tell it it's a dome pressure. I wired it up the way that it asked, and then I dropped it down. This one works for the type of sensor that it is, and you just kind of read through it. I've set everything up pretty much the way the Holley says to set it up and where to wire it to. So you can drag these out, drop them, drag them back, drop them. This tells you that it can be different kinds of 5 volt, a ground, and different types of settings there. So here's my boost controller, and here's how I have it set up. It's a dual port dome pressure control. This is what Holley recommends. This is how most of the boost controllers that are out there are set up that I've seen. Dual Holley, dome pressure only, boost first time. So you can go into boost first time, boost first gear, RPM, speed, and manual. Boost first time works great for drag racing applications because you can set it up off the trans brake release, and then when you're looking at data, if the car spins or whatever, you just look at how much time out, and then you can adjust time from there. Where the boost is at. So TPS, you can start ramp and then trans brake input. You can tell it the target, and then it'll data log and show you kind of your target and where you actually hit. Boost scramble increase, 71 PSI. That must have just been a number that was sitting in there. I don't have a boost scramble button set up, but again, you can use an IO, hook it up, and set up a scramble button to add 2, 3, 5, 20 pounds of boost or 20 pounds of air onto the top of the gate, which will give you whatever boost your car makes at that. Boost scramble decrease, again, so you can set up a button that if the car's spinning, you could grab the button or for whatever reason and it would decrease the boost. Safety setup, boost pressure above, so you can set up all your stuff here. So if the car ever sees over 24 pounds of boost, it'll revert it to wastegate. Really nice feature, super nice that the Holley will watch, and if it reads over boost, it'll just dump it out the wastegate, which is really, really nice. So you could always set that up as like a safety feature as you're working the car up. I've had it before where I was messing with just springs and preload on the gate, and I've had it lock a wastegate shut before on my 5.3. So it's nice when you have everything set up and working that it will take care of it instead of you trying to just add some by manually going after it. So dome control setup, PID, I believe all these are set up from the factory, kind of what the factory setup was on it. There's a lot of tuning, there's a lot of thought. I didn't go too far into it. I found some numbers that worked, and they worked. There's a way to tune it in. I really haven't had to get that deep into it because I used Holley sensors, Holley solenoids, and everything. So I used the kind of the base setup, and it all worked really well. Target rate, you tell it. So on mine, I'm using fixed CO2. You can use measured or compressor. I by far would recommend CO2 any day of the week. There's a little bit of cost up front, but I've been running on the same bottle of CO2. It's a 2.5 pound bottle for 3 years now. So I filled it one time, I haven't touched it in 3 years. So you tell it, it has my CO2 bottle has a set regulator. It's at 125 PSI. So you tell the Holley it's at 125 PSI. And then here's the fun part. So yeah, boost versus time, and what the heck is that? So this is my boost curve for the hard tire. As you can see, I don't want anything on the gate, and then I'd work it out a little bit, try to add some by 0.86 seconds into the run, and then I'd flat. This is flat right here because the car would spin. So instead of coming up more, I actually kept it flat through here to keep the car to try to keep the tire hooked. But then I was running into where it would still make more boost on the line, so I got to come up with a way to where the car will make maybe 1 pound of boost on the line and then ramp from there, because I know it'll hook the tire there. When it makes 3, it wants to spin the tire. So if I had the drag radial on, just for instance, and probably one of my fastest passes I've ever made, it would be somewhere like this. So I'd be, and then about a second in, all in, and then 17.5. So then this is something like what my boost ramp would look like if I had the drag radial on the car. Not exactly, but it's kind of close. And then you can kind of come in and do whatever you want. So say if the car spun right here, you could pull some power out of it, then ramp it back in, depending on the track, however you want to do it. I have it dumped because the way the car's wired, I don't want, when the bottle's open and I turn the key on, I don't want it to fill and hold the solenoids throughout the burnout. I don't need it to make 20 pounds of boost in the burnout box. So I have it dump the pressure after 11 seconds. After the pass is over, it dumps it, it relieves the valves. So then after that, you're just driving around on wastegate again, or until you grab the trans brake button. So this is all based on trans brake button. If I were to grab the trans brake right now, I'd have a little orange dot if I was hooked to the car, release it, and you can hear the solenoids open up and fill, and then this is how you set it all up. So you can come in here, you can do whatever you want. You can change this out. Say in the data log it spun at 0.5 seconds, so you want to set this to 0.4 seconds, and then you want to pull a little bit out. And this is how you adjust your boost control curve. It's real simple. It's really easy. If you have a dash, you can actually do this in the lanes without being hooked to everything. You just got to be careful you don't set this number too high. So my car on 17.5 on the gate makes approximately 17 pounds of boost. So I'm having to add a little bit more to it to get it there. So I'm starting to run into a little bit of back pressure, as you can imagine. So the more you got to put on the gate to try to make that next pound of boost is where you can start seeing if you're running into back pressure. Again, that's a whole nother discussion, but you can look it up. There's a lot of tech talk on back pressure and everything else in the systems. But so 17.5 on top of the gate. So this is PSI red on top of the gate. So the boost control solenoids will feed compressed air on top of the gate, like where the spring's at, and then it will add to the spring. So if you have a 5-pound spring and you put a pound of air on it, 2 pounds of air on it, 3 pounds of air on it, 4 pounds of air on it. So I have a 5-pound-ish spring with 17 pounds of air pressure on top of the gate, and I'm making 17 pounds. So it's almost like I'm having to make up for 5 pounds of spring pressure. So that's where you can see that I have back pressure. If not, you could have 5 pounds on the spring, add 1 pound, the car makes 6, add 2 makes 7, add 3, and so on. That's kind of where you can see that it's efficient, everything's good, and then when you start getting a higher boost, you might have to add more to make that next pound of boost. Every car is different when it's set up like this. It's all in how your hot side, your cold side's designed, how everything's set up and works. And then you can get into advanced ICFs. This is where you could literally make tables for any and everything. There's just so much here that if you want to get really nerded out on some tuning stuff, you can go in there and create tables that do this or click that or change this based on time, based on boost, based on whatever. That's how you can set up and create your own maps or own graphs or whatever that will adjust based on another event, and probably way more. But so some really cool things. Again, you go to pin map. This is how you would click here to update firmware and sync with the ECU. Here's your gauge setup. So if I was hooked to the car right now, you could watch all sensors pretty much. You can adjust these to tell it what you want to see. And that's pretty much it as far as that goes. Real simple, not real simple. This is pretty simple compared to a lot of reflash ECUs, but there's a lot to it. It is a self-tuning system, but it is by no means, I think, a system that you just plug in and it just does it all for you. It's nowhere close to that. It is remarkable at how fast it can learn and adjust and everything else, and all the safety parameters and everything else that you can do with this. And I'm only scratching the surface with a lot of this. A lot of really neat things. I want to download V5 and kind of play with some of those options too. But again, I appreciate everybody that's been watching, and if you have questions, I'll try to jump on here. This literally came from a question in the comments on YouTube from a guy that has a similar setup. He bought the Holley and he's putting it on a turbo Camaro and just asked, hey, can you show me some more things? So that's my whole basic rundown of a Holley system. I'm not sure exactly how long that went, but hopefully it's all good. Thank you guys.